Hello everyone. So we are going to start the part 3 of evaporation. So here also we are going to discuss some of the equipments which are used in the process of evaporation in pharmaceutical operation. So the next type, it is the climbing film evaporator. See, the name itself, it tells you climbing film means the film of the solvent which is about to get heated, it will climb, right? So this is the overall design of the equipments. So here we are going to discuss the different part, but let us first discuss what is the principle. So principle is that the tubes are heated externally by the steam, right? Then the preheated tubes enters from the bottom and the liquid flows up through the heated tubes. I will show you, don't worry. Then the liquid near the walls, it becomes vapor and forms small bubble, and the larger bubbles flow up with slag and strikes the deflector. Thus the deflector, it will now throw the concentrate down to the bottom. So let's discuss how it works. See, this is the overall design, right? Here we have the vent for steam inlet. This steam will come, it will hit these tubes, right? Then we have the feed. The feed is now here in this equipment. The feed will be now feeded, or the inlet of the feed, it is at the bottom. It will come through like this. So when it will pass through this area, this fluid, it will come in contact with these pipes or tubes which have the hot steam. So the heat will be transferred from this hot steam via the wall of the tube to the liquid, and this liquid, it will get heated. Now this liquid, it will move up here to this area. Here there is a deflector. Once it has reached here, the deflector, it will strike the deflector, again it will come down via this tube. Again it will be, if it is not heated properly, again it will enter here, and again it is going into the circulation, right? And generally actually what happens, the concentrated products is come from this side, means after evaporation. Sometimes suppose the tube, or sorry, the liquid has escaped via this vent or this space through this area. What will happen? This vapor, it will go in this direction, right? This vapor, or along with the liquid, it will come to this. Here is a cyclone separator. We have already discussed about the cyclone separator. This cyclone separator, what it will do? It will separate the vapor and the liquid. Thus from the cyclone separator, the vapor will escape out, right? And the liquid, from here it will come in this way, and finally you will get the concentrated product. So this is the overall diagram. So let's see the construction. So in the construction, we have the heating unit. These are the heating unit. Heating unit, it consists of the steam jacketed tubes. As I have already told you that it will have the steam, right? Long and narrow tubes are held between the plates. Here you will have long tubes, and moreover these tubes are narrow. Next is the deflector. It is placed at the top of the vapor head. This is the deflector. The main purpose of the deflector is to deflect it. Means once it will strike here, it will again come down, right? Then we have the inlets are provided for the steam and the feed. This is the inlet for the feed. This is the inlet for the steam, right? The outlets are provided for the vapor, right? The concentrated product, the non-condensed gases and condensate. So these are the outlet: condensate, concentrated product, vapor, whatever it is, all are there. So uses, this type of equipment, it is used in the insulin production, liver extract production, vitamins production, foaming liquid concentration. Corrosive solution can be concentrated using this equipment. Now how it works? So the preheated liquid feed is introduced from the bottom. Yes, one more thing I forgot to tell you. Here the liquid which will be subjected for evaporation, it will be preheated. Means you are going to increase slight temperature of the liquid here before putting into the equipment. Here from the feed, before putting into the equipment, you are going to heat it at a small degree, right? Now the steam enters the spaces outside the tubes through the inlet. So here the steam will enter, right? Next, the heat transfer to the liquor through the walls of the tube, which I have already told you. The heat will be transferred from this tube into the liquor, right? The liquor and the vapor, they moves out at a very high velocity. And then what will happen? The vapor and the liquid is separated from the upper part. If it has come out from this vent, it will get separated in the upper part, where you are going to have a cyclone separator, right? The vapors from the top, it will leave here, right? While the concentrated, it is collected at the bottom. Advantage: large area for heat transfer. First advantage. Second, it have an enhanced heat transfer. Third, it is suitable for heat sensitive material like protein, etc. Means insulin is a protein, right? So it is suitable for heat sensitive material also. It is used for foam forming liquid, and this instrument it needs very less space. Disadvantage is that it is very expensive, and construction of this instrument is quite complicated. Moreover, the cleaning and maintenance, it is quite difficult. You need a large head space for assembling this instrument, and it is not prepared for viscous or salting solution or scaling liquids. The next one, it is the falling film evaporator. Earlier one was the climbing film. Now it is the falling film. The construction is same as it is, but here you are not going to get the deflector, and the liquid, it will be come from the top end side. So this is the construction. I'll give you in details. Let's see the principle. So the principle is simple, that the feed, it enters from the top, right, and flows down the wall of the tube, right. The liquid becomes vapor and forms small bubbles, and they tend to fuse to form the layer of bubbles. They will tend, this vapor and the liquid, they will mix together, they will form a layer of bubbles, right. The concentration takes place during the downward journey here, and the vapor and the liquids are separated at the bottom via this cyclone separator. The vapor will go out, and the concentrated liquid you will get here. So let's see the construction. So it resembles the climbing film evaporator, but in an inverted position. So the feed, it is inletted from the top here of the steam compartment, right. The outlet for the product is at the bottom here, and is connected with the cyclone separator. Now how it works, the steam is supplied into the steam compartment here to heat the tubes, right. The first step. Second step is that feed enters from the top of the tube here. Whatever the liquid you want to heat, it has to be entered via this liquid inlet, right. The feed flows down the wall of the tubes. The feed will, you just see the arrow, the feed will flow through these tubes, and it gets heated rapidly. The feed absorbs the heat, the solvent begin to boil, and the solvents get evaporated, right. Then what will happen next? Now the vapor as well as the solvent, it will enter the cyclone separator. In the cyclone separator, the vapor, it will be separated from the liquid, and the liquid concentrate, it is collected at the bottom. Advantage: it is suitable for high viscous liquid, the falling film. Next, the liquid hold up time is less here, very less. Liquid hold up time is very less, as because the liquid will move very fast by virtue of gravitational force, right. The liquid is not overheated in this method. Highly acidic and corrosive feeds can be concentrated here. Means you can concentrate acidic solution and corrosive liquid solution. Disadvantage: not for suspension. For concentrating the suspension, this type of method or this type of equipment cannot be used for salting solution as well as scaling liquid. Poor feed distribution in the tube, as because the feed, it is moving only via the gravitational force. So the space near the inlet, it will have more amount of the liquid, where the tube space far away from the inlet, it will have less amount of the liquid. The feed ratio is high, here in this case, it is generally used to separate the volatile and non-volatile liquid. And concentration of the yeast extract you can make with this equipment. Manufacture of gelatin, it is done with this equipment. And extract of the tea and coffee can be easily made with this equipment. The last one for this presentation, it is the forced circulation evaporator. See, the term forced means we have to provide external energy, and the energy will be provided by a pump, right? So this is the construction. Here what we are going to have, simple, the feed, this is the feed inlet, right? It will come here, there is a pump. This pump will force this feed to move through this, right? Here we have the steam inlet, the steam will come, it will hit the tubes, this tube will be heated with the steam, right? And the liquid which we want to heat, it will come through this feed inlet. Via this pump, it is forced to move up. Here there are deflectors, right? The liquid which is less heated, it will immediately come down. Again, it is going to get circulated here, right? And the heated liquid which has heated quite more, it will just escape from this vent. It will enter here. Again, there is a cyclone separator. In this cyclone separator, the vapor will be released out from this way, and the liquid, concentrated liquid, it will come down in this way. This is the return pipe. This is known as the return pipe, and here you can collect the product, right? Principle is that the liquid is circulated through the tubes at very high pressure by means of a pump. We are going to have one pump here, right? The boiling does not take place as the boiling point is elevated here. In this process, the boiling will not take place as because the boiling point is elevated. In this case, the forced circulation, it create agitation, means the pump, it will force the liquid, right? So upon forcing the liquid will subjected for agitation, means quite mechanical shaking, which will increase the efficiency of the process of evaporation, right? So when this liquid leaves the tubes and enters in the vapor head here, this is known as the vapor head. When the liquid leaves the tubes and enters in the vapor head, the pressure, it falls suddenly, because this area, it is more, this is area, it is more as compared to this area. So immediately the vapor will fall suddenly, oh sorry, the pressure will fall suddenly. Now this sudden decrease of the pressure, it's led to flushing of the superheated liquid. So here flushing of the superheated liquid will takes place, and thus evaporation is affected. So I am showing the construction. The heating unit consists of the steam jacketed tubes. These are the steam jacketed tubes. These are the steam jacketed tubes, right? Next, the inlets are provided for the steam and the feed, right? Similarly, outlets are provided, as we all know, that for the vapor, for the product, concentrated product, vent for the non-condensate liquid, or here the condensate liquid. When non-condensate liquid means the vapor of the steam, and condensate means the steam after getting cooled, because the steam, it will transfer all its heat to the liquid. Once the steam has entered here, it may have a high temperature, but this temperature will be transferred to the liquid, which will pass through these gaps or these spaces. So this heat will be transferred to this liquid, and this steam will get finally cooled up, right? So this steam condensate can be collected here, and the remaining steam, if it is present there, that can be collected from this tube, this vent, right? So the pump is connected near the inlet here. The pump will be connected to pump the water. So working, the steam is introduced into the calandria. So this part we all know that this is known as the calandria, right? The pump, it sends the liquid to the tube with positive velocity. The pump will send the liquid to the tube with the positive velocity, means high amount of the pressure, right? Then as the liquid moves up through these spaces of the tubes, it will get heated, right? The mixture of the vapor and liquid, it moves upward with a very high velocity. Yes, because the space is narrow, pump is there, they will move at a very high velocity, right? So the mixture strikes the deflector here, and it sometimes less heated liquid again get returned or go down to this inlet via this return pipe. The vapor, it enters into the cyclone separator. The vapor, it will enter to the cyclone separator, right, and it leaves the compartment. It will leave the compartment and result in the effect, means effective separation of the liquid vapor here takes place. The concentrated liquid, it returns to the pump again. It will returns to the pump for further evaporation, and finally the concentrated product, it can be collected here. So uses, it is used for insulin and liver extract production, first of all. Next use is it can be used for crystallization or crystallizing operation, wherever you find or formation of crystal, suitable for thermolabile substances like protein, etc. Right? Advantages is that number one, heat transfer coefficient is very high. In this method, the heat transfer coefficient is very high. Next is that the salting, scaling are not possible in this equipment. It is suitable for high viscous preparation, and this advantage is that as pump and other accessories are there, this construction, it is quite complicated. It is the equipment, it is quite expensive. More power supply is needed as because we have a additional pump attached here. So this is all from these equipments used for the evaporation. Thank you everyone for your patience hearing. If you like the video, just press the like icon. You can share this video with your classmates and colleagues, and for further notification from this channel, just subscribe my channel. Thank you once again.